If you can remember just one derivative in calculus, make it this one. Mastering the derivative of the natural logarithm unlocks your ability to handle all logarithmic functions with confidence. First, let's review logarithmic functions. A logarithmic function is the inverse of an exponential function. Understanding this relationship is key to working with their derivatives. The common logarithms you'll encounter: ln x, that is the natural log, base e, or log of x, base a. That's logarithm with base a. Here's the derivative of ln x formula. The derivative of ln x with respect to x will be equal to 1 over x, given that x is greater than 0. That is simple, just 1 over x. It is also powerful because it is the foundation for all log derivatives, and it's used constantly in calculus. When the argument inside the logarithm is not just x, you need to use the chain rule. This is where things get interesting. The chain rule formula: the derivative of ln u, where u is a function of x with respect to x, will be equal to u prime over u. So you're first to identify the inside function. We call it u, where u is a function of x. Then apply the chain rule, that is the derivative of the outside times the derivative of the inside, and then we combine and reduce our answer. Let's look at it through an example. In this example, we want to find the derivative of f of x equals ln of 3x plus 1. So here's a step-by-step solution. Our inside function is 3x plus 1. We need to find the derivative of 3x plus 1, which is simply 3. So u prime is equal to 3. And then we can apply the chain rule. So our solution will be u prime, which is 3, over u, which is 3x plus 1. The derivative of the inside 3 goes in the numerator, while the entire inside function stays in the denominator. In our next example, we'll want to find the derivative of f of x equals ln of x squared. Here, our inside function is x squared. So the derivative of u equals x squared, u prime is 2x. Now we can apply the chain rule. Remember that f prime of x is u prime over u. U prime is 2x, and u is x squared. And if we simplify, 2x over x squared is 2 over x. So our final answer, f prime of x, is equal to 2 over x. Here's the general formula for the derivative of log of x base a. For logarithms with base a, that is where the base is not e, we have a slightly different formula. The derivative with respect to x of log of x base a will be equal to 1 over x times ln of a. So the numerator is always 1, the variable x is in the denominator, and we need to multiply by the base factor, so that is by ln of a. Let's look at this through an example. Find the derivative of f of x equals log of x base 2. So for log base 2, we use the formula. The derivative of log of x base 2 with respect to x will be equal to 1 over x times ln of 2. And that's our final answer. F prime of x is equal to 1 over x times ln 2. Here's an important reminder. Logarithms are defined only when the argument is greater than 0. That is, the expression inside the logarithm must always be positive. This is a fundamental property of logarithmic functions. So always check the domain before finding derivatives or solving problem. Verify that the argument of your logarithm is positive. This will prevent mathematical errors and ensures your answer is valid. Here are your challenge problems for today. First, find the derivative of f of x equals ln of 5x squared minus 1. You'll need to use the chain rule. In the next problem, find the derivative of f of x equals log of 2x plus 4 base 3. You'll need to combine the general log formula with the chain rule. And please, comment your answers below. Working through these problems will solidify your understanding of logarithmic derivatives. Log derivatives look complicated, but they follow simple rules. Once you memorize the basic formula and understand the chain rule, you can handle any logarithmic derivatives with confidence. Thanks for watching. Please like and subscribe. And don't forget, math success starts when you stay on the fast track.